To be a software engineer, some say you should pursue a computer science degree, some say you should watch 26-hour-long tutorial videos, and some say you can learn how to build a website in an hour. In this video, I will tell you how you should really learn it. It is recommended to watch the previous video first so that you can choose a direction before knowing the topics of your desired direction. So first, should you learn by pursuing a CS degree? For me, I learned it through a degree and I think it's generally good, but not compulsory. I think it's good because you don't need to worry that your learning path misses something important so the things you know are less than a degree student. Second, the degree helps you look for jobs. Not all employers require a degree, but it definitely helps. Third, you can learn with schoolmates and do projects together easily. However, the first point will be invalid because in this video, I'm going to talk about everything I learned in a degree program. You can follow it and even trim off the unnecessary parts when self-learning. So after considering these points, if you don't want to learn CS by pursuing a degree or you want to learn it before entering a degree program, it's totally fine to self-learn computer science. Next, I will talk about all computer science topics covered in my school. You can select the things you are interested in and you can learn them through online courses, books, and practice. First, these are the topics that I think all computer science students need to know. The first topic is elementary math. Not all computer scientists need to be good at math, but they should at least be comfortable with numbers and logic. As a software developer, I seldom do differentiation and integration, but basic arithmetics appear everywhere in my code. For example, if a user inputs his birthday, which is DDMMYYYY, and today is big DDMMYYYY, how can I check whether he is older or equal to 18 years old? By common sense, we can calculate his age by YYYY minus YYYY, and if his birthday has not passed, we subtract his age by 1. To check whether his birthday has passed, we check whether mm is greater than mm, and if mm is greater than mm, his birthday has not passed, and if mm is smaller than mm, his birthday has passed, and if mm is equals to mm, we check the date. As a good programmer, we should also consider whether his birthday is considered past if his birthday is the 29th of February and today is the 28th of February, given this year is not a leap year. To keep things simple, I won't discuss it in this video, but it should be enough to show that programmers always need to think over these problems carefully. Therefore, we should be able to think logically and apply elementary math comfortably. The next topic is computer programming. We need programs to let computers do what we want them to do, and is necessary for almost all fields of computer science. It is controversial whether a person should learn a high-level or low-level language first, but in my opinion it doesn't matter. You can learn other languages later and be good at them. What really matters is whether you start learning a language. It is also controversial whether programmers need to learn low-level stuff if he only works on high-level programming. I will say it helps, but it's not compulsory, so if you have limited time, you can focus on the languages that you will use the most. I think JavaScript is a good option for a high-level language, and C is a good low-level language. I chose JavaScript but not Python here because you can use JavaScript for web and mobile development without learning another language. To structure your programs and make them tidy and easy to maintain, it is also recommended to learn object-oriented programming. OOP is a way of organizing your code, and Java is very suitable for learning it. Many practical tools like Bash Shell and Git are also good to learn. Programming for a long time is hard to avoid command line interface, instructing the computers without clicking, but entering commands. The command line is powerful and can be used everywhere, including servers. In addition, many tasks like compiling programs with complex configurations need to be done using the command line, and Git is a popular tool for version control. Many of you may have experience using Google Docs for sharing documents. Google Docs is good for version control of documents, but for code, we need many more features. For example, we usually don't want multiple people working on the same file at the same time, because we can't compile the program if another person is modifying the file. Moreover, when my modification is conflicting with yours, I want to state how we should resolve the conflicts. We can also make open source projects by using Git by creating a public repository that allows others to modify the files. The next topic we need to know is data structures and algorithms. Knowing how to program is not enough. We need to write programs that execute efficiently and correctly. In an algorithm course, we will learn searching, sorting, and graph algorithms, as well as different algorithm design paradigms, like divide and conquer, greedy, and dynamic programming. To implement the algorithms, various data structures like arrays, linked lists, trees, graphs, stacks, queues, and priority queues are necessary. To evaluate the time and memory usage of your algorithm, time and space complexity analysis will be learned. To prove the correctness of your programs, discrete mathematics topics like mathematical induction and proof by contradiction are used frequently. Based on the time complexity of solving and verifying, computing problems can be categorized into different sets like P and NP. P versus NP is one of the 7 Millennium Prize problems that you can get $1 million if you can solve it. You don't have to study it, but my algorithm professor said it is a shame for a computer science student if he has never heard of this problem. Note that algorithms are very important for coding in the field, so please study hard if you want to work in big companies. The other topics can be categorized into foundations, software engineering, data science, and others. Let's talk about the foundations first. These are all compulsory courses in my degree, but I think they are not that important if you don't work in these directions, but they are worth learning if you are interested in them. Computer organization and architecture is a topic that studies the internal working of a computer system. This course may include these topics. After studying this, you can study the principle of operating system. In this course, you will learn topics like the scheduling algorithms I mentioned in the last video, as well as these things. In the network course, you will study network architecture, IP addressing and routing, flow and congestion control, and network protocols. For those who are interested in the programming languages themselves, you may study compiling techniques which talks about this, and you may also study functional programming and the principles of programming languages, which are useful for building a simple language. For cybersecurity, you may learn something like cryptography, which talks about these things. You may also learn cybersecurity, which talks about this. For software engineers, you may not need that much fundamental knowledge if your software does not require much special hardware control. Software development can be divided into the front end and the back end. The front end is responsible for handling the user interaction and displaying the user interface, while the back end is responsible for handling the requests sent by the client and managing the database. For front end, you may learn different things depending on what platforms and tools you want to use. If you want to make a web app, you may start by learning HTML, CSS, and JavaScript. To enhance coding efficiency, you may learn a framework like React, Angular, and Vue. If you want to make a mobile app, you may start with the traditional approach for writing native apps, which are using Android Studio with Kotlin or using Xcode with Swift. However, I think more people use cross-platform tools nowadays, so you may skip them to learn tools like React Native and Flutter directly. Note that React and React Native are similar, so it's easy to learn React Native after learning React. For the backend, you may learn about building, using, and optimizing the database management systems. To build it, you need an entity relationship model and database design. To use it, you need to know SQL. To optimize it, these topics may be relevant. After that, you can learn a back-end framework like Express, Django, and Laravel. You can also learn something about the cloud. AWS is a popular cloud provider. For both front-end and back-end, you also need to know the best practices of software engineering. Agile, testing, and deployment may be relevant. If you are interested in making games, you may learn the following things. Like other software, games are divided into front-end and back-end. The back-end of games and other software are similar, so the topics you need are also similar. However, as the graphics are more complicated and game scenes usually use cameras and objects instead of canvas to model real life. Different tools are used. First, you can learn how to use a game engine like Unity, Unreal, and Godot. As games, especially 3D games, require realistic modeling. Computer graphics, 3D modeling, and physics knowledge are recommended. Sometimes you need to have intelligent computer opponents. In this case, some AI may be needed as well. You need much more skills like art skills as well, but this video only focuses on the programming part. The next category is data science. A strong statistics foundation is necessary for data scientists, so you should learn calculus, linear algebra, and statistics. After that, you need to learn how to use computers to apply your statistical skills. You may learn Python or R for programming, and you may learn data scraping for data collection, data processing, exploratory data analysis, statistical and predictive analysis, and data visualization. Some machine learning may be used during the analysis, so you may learn something about machine learning as well. For artificial intelligence, the things you need are similar, but you will need more knowledge of AI. First, you may learn topics like logical inference, supervised, unsupervised, and reinforcement learning. After that, you may learn some deep learning topics like convolutional neural networks, generative adversarial networks, and natural language processing according to the direction of your research or application. For the software part of robotics, you can program a robot without any data science skills, but I put it in this category because it is very common to apply AI to robots. So learning robotics with AI is definitely beneficial. After learning the AI topics, you may need to know something about the kinematics, dynamics, and control of a robot, and you may use ROS as the framework for programming. The other category includes finance, science, and quantum computing. A CS degree curriculum usually doesn't cover these topics in detail, but there is still something related to them. For example, big data, data mining, blockchain, and cryptocurrencies are related to finance. Scientific computing, simulation, and bioinformatics are related to science, and there may be an introductory course on quantum computing. Now, you should be able to set a learning path according to the CS degree curriculum. Don't worry if you haven't chosen your direction, because you can choose after studying the things every computer scientist should know. To answer the question of whether you can learn to make a website by following a 1-hour video, I would say you can make a website, but you won't be able to make websites with special custom features, styles, and performance because you are lacking so much knowledge in this path. Computer science is all about problem solving. With problem solving skills and hard work, you will be able to find optimal solutions for many problems. How to learn computer science is the first problem computer science students need to solve. From my experience, it is a complex problem, as different topics and different people may need different methods. A tip from me is to use different resources. In general, I think learning from classical books is good for learning theory that doesn't change frequently. Online resources and projects are good for learning practical skills, and working with experienced programmers is efficient in learning the best practices. In the future, I am planning to make tutorial videos covering these topics, so please subscribe if you are interested in this. Please like and subscribe if you find this video useful or interesting. Hope these videos will be helpful to you.